Yeah, first of all, a warm welcome to today's webinar, Shopware 6 on Kubernetes in the cloud. Anna and Tomasz will explain you how to deploy Shopware 6 on a Kubernetes cluster and how you can profit from its capabilities like autoscaling, self-healing, and automatic deployments. So before kickoff, let's have maybe a small introduction round. You may have been wondering who is talking right now. My name is Claudia Blazinski. I'm working as a key account manager in our international sales department, taking care of our international partners and customers. And now maybe I can hand over to Anna and Tomasz to introduce themselves and start with a very interesting topic.
Thank you, Claudia. Good morning, everybody. Thank you for the time that you decided to spend today with us. My name is Anna. I'm a CEO of Kiwi. I have been involved into software development for 17 years. Long story short, I'm a keen of open source and the concept that the technology should resolve real life problems and make the world a better place. So, Tomasz, if you could take it over.
Hello, everyone. Nice to see you all around here. I'm a CTO at Kiwi with 20 years experience in web applications development. Yeah, and I would like to say a few words how our story, how we started getting experience with containers. Which was around 2015 when Docker became popular, and we decided to try it out and replace background we used at the time. And this turned out to be a very good solution and very good decision. It worked well on every dev device, regardless it was a Mac or Linux or Windows. But soon after, we realized that it would be great if we have a consistent also staging and production environment. So we decided to try it out with the project at the time we worked on, and that also was very successful because we noticed a lower rate of bugs related to strictly different configurations, because many probably you experience in your already experienced such a situation where there was a problem on staging, but you couldn't reproduce it on your dev. That was very helpful to deploy applications in containers. In the meantime, around 2015, Kubernetes was released and was getting popularity. So we decided also to try it out with one of our Magento 2 projects, and we started building a proof of concept Magento 2 on Kubernetes. And this was also very successful and working perfect. And also soon after, Shopware 6 was rolled out, and I was very excited about it because it followed the API first approach, and I knew that it's going to be perfect fit for cloud native type of applications. So, and that's how this project was born.
Thank you, Tomasz.
Thank you.
So quickly about Kiwi. At Kiwi, we build custom web and mobile applications and e-commerce software to support our clients' business growth. We particularly focus on highly available stores, which can be scaled easily in line with demand. We work for international clients, mainly from Europe, and since 2020, Kiwi has been proud Shopware partner, we cherish a lot our cooperation, and I think it's really exceptional. And yes, let's jump into agenda since we have a lot of work today. So I would like to introduce you to the basics of Kubernetes. And after that, let's discuss why actually you need Kubernetes. The next one is our proof of concept, Shopware 6 on Kubernetes in the cloud. How to autoscale Shopware 6 on Kubernetes, self-healing, and last but not least, GitHub's pattern. And as Claudia mentioned, at the very end, we'll have, live demo of Argo CD. And after live demo, we will do question and answer session. We decided to spend 10 minutes on that. What is Kubernetes? To set the stage, I would like to shed some light how Kubernetes was created. And Google was using 2 internal projects to maintain the containers on a large scale, I would even say huge scale, in the projects like Gmail or Search, and the most probably some other. And their names were Borg and Omega. Borg was a project, was a unified container management system. Because of course, in such a big company, they couldn't manually restart a crashed or damaged container when they had millions of them. Omega was an offspring of Borg. The goal was to improve the software engineering of Borg ecosystem. And Omega stored the state of a container in a centralized place so that the different parts of the cluster could access it. So it sounds very similar to Kubernetes. A turning point in cloud services was when Google decided to use their knowledge and experiences in maintaining, let's say, huge scale projects and build an open source product called Kubernetes. So they gave it to the community. In a traditional way, you deploy your application to the virtual machine or to the cloud or even to the bare metal, whatever your wish is. Kubernetes adds an abstraction layer between the operating system and an application. However, here I would like to bring your attention to the Kubernetes API, because Kubernetes has a modular architecture and a communication happens via APIs. You can, even if that's your wish, you can use a set of Raspberry Pis, whatever the project is. Kubernetes is a container orchestration tool. What does it mean? It means that this is a tool that automates deployments, scaling, and management of applications which work in the containers. Below Kubernetes API, you can use the services of the providers of your choice. It can be Microsoft Azure, OVH Cloud, AWS, DigitalOcean, or Google Cloud, or any other provider who has implemented Kubernetes. The implementation of Kubernetes varies from one provider to another. The concept is, of course, still the same. Kubernetes follows declarative approach. What does it mean? I will give you a very, let's say, simple example. Let's imagine that you would like to have 4 replicas of Shopware 6 containers running. And instead of repeating to Kubernetes, dear Kubernetes, start Shopware 6 container for me. The second time, dear Kubernetes, start Shopware 6 container for me. And 2 more times, you say, dear Kubernetes, I would like to have 4 replicas of Shopware 6 container running. Please make it happen for me. It means that the cluster admin operator provides a desired state, let's say your wish, of the cluster elements. Kubernetes works in a loop and constantly checks the state of a cluster, react on the circumstances, let's say some events like traffic spikes, and keeps a cluster in the desired state. Before we move forward, I would like to discuss some basic elements of Kubernetes cluster with you, so it will be easier for you to follow the rest of the presentation. In the Kubernetes cluster, we have pods. and the pods represent the containers. A single pod can have one container or more, and containers within a single pod, they share the same network. That's crucial, I would say. The nodes are physical or virtual machines. And last but not least, we have a service, and a service is an abstraction where you define how to connect to a pod or to the group of pods from within a cluster or from outside a cluster. Why do you need Kubernetes? And here I have two perspectives on that. One is that in technology, from time to time, there appear some frameworks or systems which are the game changers. And I think that Kubernetes is one of them, the same as it was with the containers or with Linux or some other technologies. And sooner or later, when you will need to answer a question if I need Kubernetes or not, if you would like to have scalable, automated deployments and efficient resource usage, you will need to implement Kubernetes. The second perspective is that time flies, and in technology, time flies extremely fast. What I would like to say by that is that for the short term, you might not use Kubernetes, but long term, it should be on an innovative company roadmap. Let's jump into our proof of concept of Shopware 6 on Kubernetes in the cloud. So as Tomasz mentioned, our primary goal in this project is to deliver highly available and scalable Shopware 6 setup on Kubernetes in a cloud, which can be applicable to multiple cloud vendors, the provider of your choice. Its development version is open source and available on GitHub because we love to share the knowledge with community. We are currently working on the production version of the project, and this is what we will present to you today. Before I will pass it to Tomek, one more piece of knowledge that I would like to share with you is how to autoscale Shopware 6 on Kubernetes cluster. So as you know, because you all, I think, work in e-commerce, that we need to face traffic spikes and we need to deal with them. They can be caused, of course, by different events like Black Friday or some campaigns. Sometimes TV appearance can cause quite a big traffic spike, and the infrastructure needs to be ready for that. And autoscaling that's a good news. It's ready in the Kubernetes infrastructure, and it's an essential feature. There are two types of Kubernetes autoscaling. One is on a cluster level, and the second one is on a pod level. Their way of working is essentially different. So let's take a closer look at each one. I will start with cluster autoscaling. And the idea is that if a node is complete, which means no place for a new pod, a new node is added to the cluster. When CPU and memory utilization in a node drops below a given threshold, a node is deleted. And this is a work of cluster admin who needs to set up the resource requests and limits per node so that Kubernetes scheduler can place the pods in the node more optimally. Cluster autoscaler implementation varies from one provider to another. However, of course, the concept is still the same. And what can I say is that it's very comfortable and efficient way of autoscaling. The second type of autoscaling is horizontal pod autoscaling. So as you can, even in the name, you have pod, so it's on a pod level. And the horizontal pod autoscaler can automatically scale the number of the pods in a cluster based either on the current resource usage or by external metrics. The external metrics they are kept here in the metrics server, and metrics server is an essential component that runs in a Kubernetes control plane and provides CPU and memory thresholds to Kubernetes API server. So once we know how autoscaling works in Kubernetes, let's jump into our proof of concept architecture. So Tomek, if you could take it over, I will stop sharing my screen. Give me a moment. Okay, you should be able to share your screen, I think.
All right. Yeah.
Yes.
Is it visible now?
Yes, it is.
Okay. All right. So here I want to give you a quick overview of how a Shopware 6 cluster looks like in our setup. So first we start from a load balancer, and this component here is outside of the cluster because in most of the cases, most of the cloud providers is available as a service. And load balancer is responsible for redirecting traffic to the cluster. And in most of the cases, it's responsible also for SSL decryption. So next component already in the cluster is ingress. And ingress is a service which has defined rules to route the traffic, HTTP traffic or HTTPS traffic, to the right pods. So in our case, those pods are Shopware 6 server, and this pod is consisted of Nginx and PHP FPM and Shopware 6 installation. And it has the horizontal autoscaling implemented. So when there is a demand, new replicas are created. Next component is Elasticsearch cluster. Important is to have more than one node, and then we have high availability. So when one goes down, then the search is still working. Then we have a MySQL replication. So we have one master database and 2 or more slave databases with a failover functionality. So for example, when master goes down for any reason, one of the slaves is elected as a master, and there is no data loss. So then it gives the time to a DevOps person to find out what's wrong with the master and fix it. But the database is still working. Next component important is to have a shared media storage because it's every Shopware 6 pod has to be immutable, so it can come and go and shouldn't have any state. And everything what is common and what is shared for all pods is stored in this media storage, which is media files, so the product pictures or static pictures, static files, and also a sitemap or thumbnails and everything like this. And here there are multiple options to have it. So one of this, I think the simplest is to have a regional volume available at most of the cloud providers. So with some replicas in different regions. And for example, in Google, this is mounted as a with an NFS version 3 protocol, but it can be different in the different cloud providers. For example, at AWS, it could be S3 block storage. Other providers have also such a functionality, so there are many options to this. But important is to have a common storage and highly available. So when there is a failure, then still no data is lost. And finally, Redis. So 2 instances, one for storing session and one for cache. And also they have to be common for all Shopware 6 instances. So the cache and session is shared across all users, all instances. Okay, so here's an overview. And I want to say a few words about how to achieve high availability and self-healing Shopware 6 configuration. Partially, I mentioned already on the diagram before, but here I want to just point out some 6 assumptions have to be met to achieve high availability. First of all, is to have a replicated Kubernetes control plane on 3 nodes or more. So, and control plane consists of crucial Kubernetes components like API server or database storage to store the state of the cluster, scheduler, which is scheduling the new pods on nodes, and controller manager, which acts on when, for example, node is unavailable and it has to, for example, move all pods or recreate or missing pods on another nodes which are available. So it's important to have it replicated, because when a node goes down, then the cluster is still operational. Then this distributed media storage with replication to ensure that no data is lost if, for example, a hard disk fails physically. This could be done with, for example, with the managed services like S3, but it could be also self setup with, for example, Ceph-FS with a set of hard drives, network hard drives connected together with the cluster. Next is a database replication with failover capability. So when master goes down, then still database is working. And I think this is the most crucial components. And of course, there has to be constant backups done of the database, just in case. Elasticsearch cluster on 3 nodes or more with indices replication. So the same situation when one node goes down, the search is still available. And also it's important to have a central storage for logs and aggregation of the logs. Because if we have such a distributed setup, there are many components which generate logs. Even Shopware, if we have, for example, 50 replicas and every replica of the server generate own logs, we have to have a central place to be able to search through those logs and find if anything was wrong, there was any error. Otherwise, it's not possible whatsoever. And finally, the ideal situation, if we have a mirror cluster in a different region or in a different cloud provider in case of some kind of disaster, to be able to recover quite quickly. And probably you remember an incident from the beginning of this year happened at OVH data center in Strasbourg, when there was a fire and almost whole data center was burned, and lots of customers of theirs lost their data. And here, this is a tweet from the CEO of OVH recommending to activate a disaster recovery plan. But I believe many of their customers didn't have one. Okay, so this is about high availability setup. I would like to hear also say a few words about GitOps. GitOps is an evolution of infrastructure as a code with Git in the center. So Git as a single source of truth. So we store in Git all Kubernetes manifests in YAML files, also server configuration files, provisioning files like in Terraform or Ansible. So we implement the usual dev workflow with pull requests and code reviews and running some validation tests against them before deploying. And one of the tools for GitOps on Kubernetes is Argo CD, which I would like to quickly show you how it works in a real life situation. And I would like to also show you some demos of horizontal pod autoscaling when the cluster is having some load, because we prepared some load test in Locust. So maybe let's quickly jump to the live demo. Okay, so here's the demo store I deployed to Kubernetes. So it's just standard demo store with 1,000 demo products generated. Right now there is no traffic on it. This is the UI of Argo CD. So most of the features of it are available in the command line tools, but this UI is also very nice and can provide some basic stuff like, for example, synchronizing between Git and the cluster. So in short, Argo CD is constantly monitoring the state of the cluster and the state of a given branch in Git with the cluster setup. And if everything changes, it notifies, or if there is such a will, so we can set it up like this, it can also automatically synchronize. So here we have everything in sync. And I want to try it out and deploy a new version with the new plugin installed. So you can see how it behaves then. So let me quickly switch to the code. So here I'm going to change the image version name to deploy. So I have already prepared an image with this plugin. Okay, and let's push it to the repository. Okay, so here I would like to quickly show you those windows. On the left-hand side, we have running pods with the Shopware server. Yeah, initially three instances. This app tasks pod is containing only the message queue consumer. So instead of having it in administration, then we have a separate pod for this. And on the right-hand side, we have nodes, currently 4, but by design was the minimum number was 3, but yeah, before the presentation, I run the tests which auto-scale it to 4. Yeah, so here let me quickly push the plugin. Okay, we have to push it, but normally it should go through the code review and the whole workflow, but let's make it quick. Here we refresh. It should show us that something changed. Okay, so and then we can now synchronize. And it's synchronizing, so we can more observe what's happening here. It should roll out a new version soon. So here you can see that the strategy is rolling updates, so it replaces one pod at the time. So you can see that it created 2 new, which are starting up. So this column means here that there are 0 out of 1 pod containers ready. So 0 means that they are still starting up. So when the roll is finished, then we will be able to activate the plugin. And when they start up, then Kubernetes will automatically shut down the old version. So to ensure there is no downtime. You can see the first one is already ready. Then it's terminating now the one of the old ones here. Take a second. 2 seconds. Here it's showing that it's synchronizing. I can also show you some features of Argo CD. So it's also giving some insights about the cluster state. So here are the view of nodes and how many resources are available in the given node. Next thing here, I can show you is the cluster overview. So you can see that we have configuration files and all elements in the cluster, like Redis, Elasticsearch. Here in this view is also showing the request flow. So it's coming from the internet through the load balancer ingress. And here you have the application server, so Shopware server service redirecting traffic to all the pods created. We have a Elasticsearch and three instances on every node each. And we have a Redis and session and cache. Okay, so let's see. It shows that it has been already synchronized. Okay, so let's see, and see that all pods have been already replaced. So we have a new version rolled out. So now we have to activate the plugin. Let me reload the admin. Okay, we have a plugin installed and visible, so we need to install it first. And okay, need to wait until this page reloads. And it's activated. And there is one more thing we need to do, but only in the case of installing a new plugin. We have to repeat the rollout because there is an issue when installing assets. Shopware by default is installing assets only from the active plugins. So when we rolled out the new version, the plugin wasn't active yet, so it didn't copy the assets to the public folder at that time. So we have to now, when the plugin is active, we have to restart. We have to restart the rollout. So there is a rollout restart. So it will basically recreate all pods once again. So now, if when the plugin is active, it will deploy also the static assets. Because right now, when we test it, so when I reload the page, you can see that here the plugin is working. There is the message showing up, but it lacks of styles. So we have to wait until all pods have been reloaded. It would also work if we restart all the pods, but this is I think the easiest solution to restart the rollout. Then it also restarts all pods automatically. Okay, so I think we can try it again. Voila, we have the plugin with the styles. Okay, so let's come back to the presentation. So the next demo I would like to show you is the horizontal autoscaling and the load test. Let's jump here. For this, we used a tool called Locust for distributed load testing, and we wrote a bunch of tests which more or less simulate the the users. So they browse category, they enter homepage, login, make a purchase, view products, make search for products, and register themselves. So yeah, okay. So let's start the test. First, we have to provide the number of concurrent users. So let's have 200. Then this how many the value how many users are created per second. So let's say 5. And number of users to increase per step. So 10, and the step duration 30. So it will add 10 new users every 30 seconds. So let's start. And here we have a live chart showing the number of requests per second. Here we have the current number of concurrent users. And here we have response times. And the green line is showing the median response time. And the yellow one is a 95th percentile, which means that 5% of the requests are slower than this value. Usually in the beginning, when you don't do a cache warm-up, providing high traffic results in not very good response times, but usually they improve in time when the cache is created, cache entries are created. So let's quickly jump into the console. So you can see that it's now already creating new pods. So the autoscaling is working. Now let's wait a moment. So you can see quickly, shortly, it should create new ones when there is a demand. And it works in the way that I defined the limits each pod can use of the resources, which are CPU and memory. And if the utilization is exceeding certain threshold, in this case, this is 70%. Kubernetes is automatically creating new pods. So you can see that three new starting up. Okay, so this is it, I think. I wanted to show you. Let me quickly return to the presentation. How you can contribute. Here there is a link to our GitHub project, Shopware 6 on Kubernetes for developers. It contains some additional things like Xdebug and DevSpace configuration tool. DevSpace is a useful tool for code synchronizing and creating tunnels for Xdebug. So yeah, you're very welcome to contribute here. And also I recommend to check out our article about developing Shopware 6 directly on Kubernetes.
So please feel free to join. We would be happy to answer open questions, and then of course stay in touch for the future.
Thank you.
Thank you. Thank you everyone for participation, and thank you, Claudia, for organizing it.
You're welcome.
Thank you very much, Claudia. Thank you everybody for your time, and have a good day.